We live on a planet called Earth. Earth is part of a huge family called the solar system. The solar system is a group of objects made of the sun in the center and many bodies that orbit around it. The boss of this family is, of course, the sun. The sun makes up about 99.86% of all the mass in the solar system. All the other planets, moons, asteroids, and comets together are only about 0.14%, and most of that 0.14% is in the four giant planets, Jupiter, Saturn, Uranus, and Neptune. In this video, we will travel through time and space like a story and learn what the solar system is and how big this world really is. 1. The beginning of the universe and the birth of the solar system. About 13.8 billion years ago, there were no stars and no planets yet. The universe was just a tiny, extremely hot space, filled only with energy. Then suddenly it began to expand explosively. This is what we call the Big Bang. After the Big Bang, the universe kept expanding. At a certain early stage, the expansion suddenly sped up. This rapid early growth is called inflation. During inflation, tiny quantum fluctuations in space were stretched out, and these became the seeds of future galaxies and stars. As the universe expanded, it cooled down. Hydrogen and helium gas began to form. Our solar system also started from one part of this huge cloud of gas. About 4.6 billion years ago, a cloud of gas and dust spread over several light years began to gather under its own gravity. As more material fell toward the center, gravity there became stronger, and the whole cloud started to spin and flatten out like a disk. This is called a protoplanetary disk. Inside this spinning disk, atoms, gas, and dust grains bumped into each other. These collisions turned motion into heat, and the center of the disk became hotter and denser. Eventually, the central part became a ball of gas. The hydrogen inside this ball began nuclear fusion and started to shine. This was the early sun. Further out in the disk, gas and dust clumped together into many small objects. At first, they were tiny planetesimals and asteroids. They kept colliding and merging, slowly growing larger and larger. In this long battle of small worlds, the biggest bodies in each orbit gained the strongest gravity and started to dominate. These winners became the planets we know today. This is how our present-day solar system was formed. 2. The Sun, ruler of the solar system. At the center of the solar system is a huge star, the Sun. The mass of the Sun is about 333,000 times the mass of Earth. It holds almost all the mass of the entire solar system, so it is truly the king of the solar system. Inside the Sun, strong gravity squeezes hydrogen together. Hydrogen nuclei fuse into helium in a process called nuclear fusion. Gravity tries to crush the Sun inward, while the energy from fusion pushes outward. These two forces balance each other perfectly, so the Sun stays round, hot and shining steadily, and the Sun sends out many kinds of electromagnetic waves: gamma rays, X-rays, ultraviolet rays, visible light, and infrared rays. Among them, visible light is what our eyes can see. This sunlight brightens Earth and provides the energy that supports life and our daily activities. 3. The inner worlds: Mercury, Venus, Earth, Mars, and the asteroid belt. Near the Sun we find small, dense planets made mostly of rock and metal. These are called the inner planets. There are 4 inner planets in order of distance from the Sun: Mercury, Venus, Earth, and Mars. Mercury, a tiny world of fire and ice. Mercury is the closest planet to the Sun and also the smallest. It goes around the Sun in only 88 days. Its orbit is strongly elliptical. On Mercury, daytime temperatures can rise to hundreds of degrees Celsius, while nighttime temperatures drop to hundreds of degrees below zero. Even in this extreme world, there are shadowed craters where sunlight never reaches, and in those places, ice can exist. Venus, Earth's twin with a hellish surface. Next out from the Sun is Venus. Venus is very similar to Earth in size and density. For this reason, it is sometimes called Earth's twin, but its environment is completely different. The atmosphere of Venus is made mostly of carbon dioxide and is extremely thick and heavy. The pressure at the surface is about 92 times that of Earth. That is like being 900 meters under the ocean. Powerful greenhouse effects make the surface so hot that even lid would melt. It is not a place where humans could live. Venus also spins in a strange way. It rotates very slowly and in the opposite direction to most other planets. One rotation takes about 243 Earth days, so one day and one night on Venus each last well over 100 Earth days. In the distant past, Earth also probably had a lot of carbon dioxide and might have been a very hot planet like Venus. But Earth had plenty of water. Oceans formed and absorbed much of the carbon dioxide, changing the balance of the atmosphere and creating the mild climate we enjoy today. If all the carbon dioxide now locked in Earth's oceans and rocks were released back into the air, our atmosphere would become very similar to that of Venus. It might be that the long-lasting presence of liquid water is what separated the fate of Earth and Venus. Mars another possible home. The next inner planet beyond Earth is Mars. Mars has a diameter about half that of Earth and only about 1/10 the mass. Its gravity is about 40% of Earth's gravity. Because gravity is weak, Mars has trouble holding onto its atmosphere, so today the air is very thin. Even so, the length of a day on Mars is almost the same as on Earth, about 24 hours. On its surface we see valleys and channels that look like places where water once flowed. Dust devils and storms also occur. Because of these features, Mars is often called the most Earth-like planet in the solar system. Many people think that in the future, humanity might try to terraform Mars, to change it into a more Earth-like world and make it a second home for humans, especially if our civilization grows enough to use energy from the entire solar system. Asteroid belt, unfinished planetary building blocks between Mars and Jupiter lies a region called the asteroid belt. Here, countless rocky bodies orbit the Sun. Some are only a few millimeters across, others are several meters, or even many kilometers in size. These objects are thought to be the leftover building blocks of a planet that never formed. Near the asteroid belt, the strong gravity of Jupiter constantly disturbs their orbits, so the material could not clump together into a single large planet. People often imagine the asteroid belt as a crowded region where rocks are packed tightly, but in reality the density is very low. A spaceship could fly through the belt with almost no chance of hitting anything. The largest body in the asteroid belt is the dwarf planet Ceres. Its diameter is about 1,000 kilometers, and its own gravity makes it nearly spherical. Meanwhile, many smaller asteroids still collide with each other. Fragments from these collisions sometimes fall into Earth's atmosphere and become the shooting stars we see in the night sky. 4. The outer worlds. Jupiter, Saturn, Uranus, and Neptune beyond the asteroid belt. 4 giant planets orbit the Sun. Jupiter, Saturn, Uranus, and Neptune. These outer planets are made mostly of hydrogen, helium, ammonia, methane, and various ices, so they are very different from the rocky inner planets. Jupiter, Earth's bodyguard Jupiter, is the largest planet in the solar system. Its mass is about 2.6 times greater than the combined mass of all the other planets. Its diameter is about 10 times that of Earth, yet it rotates once in only about 10 hours. That is extremely fast. Because it spins so quickly, gravity at the equator is slightly weaker than at the poles. Jupiter's upper layers are mostly hydrogen. Deeper inside, helium becomes more abundant, and at great depth, the pressure is so strong that hydrogen may become a strange metallic fluid. On the surface, we see colorful bands and giant storms. The most famous is the Great Red Spot, a huge storm larger than Earth. The patterns we see are formed by clouds and winds, and they slowly change over time. Jupiter's enormous mass gives it powerful gravity. It pulls in asteroids and comets that pass nearby, and sometimes breaks them apart in huge impacts. Thanks to Jupiter, many dangerous objects are deflected or captured before they can reach the inner planets. If Jupiter did not exist, asteroid and comet impacts on Earth would likely be much more frequent. In that sense, Jupiter acts as a bodyguard for our planet. Saturn, a giant planet with floating density and beautiful rings. Outside Jupiter, we find Saturn. Saturn's volume is about 760 times that of Earth, but its mass is only about 95 times Earth's mass because it is made mostly of light gases. Its average density is only about 1/3 that of water. This leads to the famous expression, if you could put Saturn in a huge pool of water, it would float. Saturn's atmosphere is about 96% hydrogen. Its overall composition is similar to that of the young Sun. Saturn is best known for its magnificent rings. These rings are made of countless pieces of ice and rock, ranging from tiny grains to large chunks. They are thought to have formed when a moon or other body was torn apart by Saturn's strong tidal forces. Uranus, a mysterious blue planet lying on its side beyond Saturn, lies Uranus. Unlike Jupiter and Saturn, Uranus has a calm blue-green color and feels somewhat mysterious. Because it is far from the sun, it is very cold. Beneath its thin atmosphere, there are deep layers of liquid and icy materials such as helium, methane, and ammonia. The most unusual feature of Uranus is its tilt. Most planets spin like a spinning top standing upright, but Uranus is tipped almost onto its side. It rotates like a rolling ball. The most likely explanation is that long ago Uranus was hit by one or more giant objects. Computer simulations show that 2 big collisions could produce the tilt we see today. Uranus takes 84 years to orbit the Sun once. Because its axis is so tilted, the poles experience extremely long seasons. At the poles of Uranus, daytime can last about 42 years, followed by about 42 years of night. If you were born on Uranus, you would experience polar day and polar night only once each in your entire life. That sounds a bit lonely. Neptune, the planet of the strongest winds. The most distant planet from the Sun is Neptune. Unlike Uranus, Neptune is an ice giant made of gases and ices in different states. Gas, liquid, and solid. Its atmosphere is mainly hydrogen and helium, with some methane, which gives it a deep blue color. On Neptune, incredibly strong winds blow across the atmosphere. These are the fastest winds in the solar system, reaching speeds far higher than any hurricane on Earth. Neptune is a huge planet, but it is so far away that it was discovered relatively late in history. Its discovery is closely tied to the law of gravity and the motion of Uranus. Astronomers noticed small irregularities in Uranus's orbit and predicted that another planet must be pulling on it. This led to the discovery of Neptune, a story that shows the power of mathematics and physics.
5. Beyond Neptune, the Kuiper Belt and Pluto. For many people, the solar system ends at Neptune, but in reality, many more objects exist beyond it. Just outside Neptune, there's a region filled with icy bodies. This area is called the Kuiper Belt. There may be over 100,000 objects here with diameters greater than 50 kilometers. The most famous member of the Kuiper Belt is Pluto. Pluto was once called the 9th planet of the solar system. However, after astronomers discovered many other similar-sized objects, they redefined the term planet. Pluto did not meet all the new conditions, so it is now classified as a dwarf planet. Solar wind and the heliosphere. How far does the sun reach? The sun sends out more than just light. It also blows a constant stream of charged particles called the solar wind. The solar wind is made of electrons and protons that escape from the sun's hot outer atmosphere. Near Earth, the solar wind can travel at hundreds of kilometers per second. When this flow of particles reaches Earth, it is deflected and guided by Earth's magnetic field. Some of the particles spiral down toward the polar regions and collide with atoms in the upper atmosphere. Those collisions create the beautiful lights we call the aurora. The solar wind continues past Earth, past the outer planets, and out beyond Pluto and the Kuiper Belt. Far away from the sun, it gradually slows down as it pushes against particles and magnetic fields in interstellar space. The boundary where the solar wind pressure and the pressure from interstellar space balance is called the heliopause. The region inside this boundary, filled with solar wind, is called the heliosphere. In 2012, NASA's Voyager 1 spacecraft crossed the heliopause and became the first human-made object to enter interstellar space. It is now traveling in the darkness between the stars, still sending signals back to Earth. 7. The Oort Cloud and the Sun's gravitational territory. In theory, gravity from the Sun reaches out to infinity, but if we ask, how far out can the Sun still hold onto orbiting objects? Astronomers imagine a distant region called the Oort Cloud. The Oort Cloud is thought to be a vast shell of icy bodies surrounding the solar system in every direction. There may be trillions of small objects there. Its outer edge may lie around 100,000 astronomical units from the Sun, about 2 light-years away. This enormous distance marks the approximate edge of the Sun's gravitational territory in space. 8. Our neighboring stars and the Milky Way, the star closest to the Sun, is part of the Alpha Centauri star system. Its nearest member, Proxima Centauri, is about 4 light-years away. 4 light-years sounds unimaginably far, but if the Oort Cloud really extends to about 2 light-years, then the nearest star is only a bit beyond the edge of the Sun's influence. Near the Sun, there are several other stars within a few light-years.
All of them interact very slightly through gravity. On a much larger scale, billions of stars, including our sun, are bound together by gravity to form our home galaxy, the Milky Way. Black holes and dark matter also play a role in shaping this giant structure. 9. Humanity and the future of space. In the 4.6 billion year history of the solar system, life appeared on Earth, evolved, and eventually gave birth to human civilization. Humans developed tools, science, and technology, and finally gained the ability to leave their home planet. We first set foot on the moon only a few decades ago. Compared to the age of the universe, that moment is like just a second ago. The Oort Cloud, the neighboring stars, and the wider galaxy are still far beyond our physical reach. We cannot go there yet, but we can observe them with telescopes and study them with physics and mathematics. Our theories and technologies are advancing faster and faster. Just as the invention of airplanes made our planet feel smaller, future breakthroughs in space travel may make this universe feel closer and more familiar to us. The solar system is not just a set of dry numbers or distant objects. It is the stage on which the story of our sun, our Earth, and our own lives is unfolding. And this story is still continuing right now as we look up at the sky.